For the last presentation, Bernadette, Raquel, and myself will present the GeoGebra program and show how you might use it in your calculus class. We want to show you the basic use and features of the program, and we're hoping that'll inspire you to try the program yourself and maybe even use it with your students. We're going to try and give you the tools and resources so that you can use the program immediately in your classroom. You do have to install GeoGebra, and it is free and open source with downloads for every operating system, including tablets and phones. Check out our video description where we've put some notes and links to useful files and resources, and we will also include the finished demonstration file that we use during the video. When you open up GeoGebra, you're going to see 5 basic areas. Up at the top you've got your menu options. Below that you've got your toolbar. We've got on the left hand side an algebra pane open. We've got a graphics window or pane open. And on the bottom here we've got our input bar. Okay, the first thing we'll take a look at is SlopeField. If you look at the bottom of the screen at the input bar, I start typing slope and different options come up. I'll go ahead and use the mouse to select SlopeField, and it asks for f, a function of x and y, as a parameter. So there's our function that was given in homework 10 question 2. As I hit return, you'll notice in the graphics pane we see a nice graph of our slope field, and over here in the algebra pane it shows that object, that slope field, which we can now right click on, and we could check our object properties, or in this case I'm going to go ahead and delete. As you might imagine, GeoGebra makes a great graphing tool. Down in the input bar I've entered f of x equals x squared, and you can see our graph comes up in our functions over in the algebra pane. Scrolling and panning is really easy in GeoGebra. You can just grab anywhere on the pane with the mouse and use the scroll wheel for zoom. If you use the move graphics view, you can also get on the axis and change the scaling easily on the x and y axis to make the graph more viewable. If I use the left and right arrow keys on the keyboard, I get the same effect, and if I use shift left and right arrow, I can compress and expand the x and y axis also. The graphics pane has a drop down menu, and I can turn off and on the axes and the grids. And if I click over the little house, it scrolls me right back to my default view where we started. Another really cool feature of GeoGebra is when you're studying translations and shifts of functions. I'm going to come over here and select my move tool, and watch what happens to my function in the algebra pane as I come over here in the graphics pane, and I'm going to click and drag my entire function. I move the vertex to 4, 3, and you can see the equation reflects that. I can use my left, right, up and down arrows to do the same thing on the keyboard. And again, a nice connection between what you see algebraically and what you see for a graph. Now I want to set this up to calculate the area under a curve. So the first thing I'm going to do is come over here and select point on object to put a couple of points on my x-axis. These will act as my limits of integration. I'm also going to put a couple of points up here attached to the function. If I come in and drag these points around now, we notice the values change dynamically over here in the algebra pane. I've got a drop down menu, so instead of value, what's set to now, I can change it to see the command. So now you can see the command that I would have typed in to get the point A. So if I type that down into the input bar, I would have had the same effect of generating point A or any of these other points. In order to help visualize where I'm doing my integration, I'm also going to add this line segment between points A and C. So that was off the segment tool and between A and C. I still have a problem though, is when I drag A, nothing happens to C. So I'm going to redefine point C. I'm going to come over here and right click on C, check object properties, and I'm going to redefine point C to be the x value from A, from the point A, and then I'm going to put that same x value into my function f. Let's see what that gives us. Now when I drag A, you'll see that C goes along with it. To clean things up, over here I'm not going to actually need to see point C, so if I click on the dot, that turns it off. I won't see anything of it. For segment G, I want to see the segment, but I don't need to see the label, so I right click, turn off the label. And my last thing is I'll move this label down below so that I'll have some room in between. So I can move that label wherever I like. Now I'm going to go ahead and do the same thing to the other side. Now I'm ready to enter my integral command. So I'm going to create a variable called area, and I start typing in integral. I'm going to use the function f, x value from A, x value from B, and hit enter. And you can see that I've got my area displayed. I'll move that label down below what's displayed. Right now it's under command. I'll switch back and forth. I'm going to go to value, and now you can see the area displayed. Up here in options, I'm going to make sure I'm set up to 3 decimals, since that's what we were using in Canvas. And so now I've got a nice dynamic display of area under the curve. I can move the curve around for different points. I can move my limits of integration, A and B, back and forth, left and right. And so that's a pretty nice feature. I'm going to go ahead and enter the commands for calculating Riemann sums for this, and it'll be the same way, and I'll show you in the command section what that looks like. Okay, before I do the Riemann sums, I'm going to input a couple of ways to interact with the program. I'll come in here under the slider tool and select the input box. Find a location, and f of x equals will be the caption, and I'm going to link that to the f of x function. Now I should be able to come up here and change my function easily. I'm also going to add a slider. This will give me the number of rectangles to use for my Riemann sums. I'll call this variable n, and we'll let that go from 1 to about 8. Got a couple other sliders I want to, eventually I'll do an angle for when I do turn this function around. You can see I want to call this, I got the option over here to use Greek letters, so since I'm going to do an angle, I'll use a Greek letter. I'm going to make this angle from 0 to 2 pi. And then I'll make one last slider that I'm going to use later on for selecting different kind of Riemann sums. Okay, so I've got a couple values selected. Okay, so now I've entered all the commands to do several different kinds of Riemann sums. The problem is right now they're all displayed one over the other. I could come through here and turn these on and off manually so that I just see one at a time. But what I'm going to do is I'm going to come in here, I'm going to right click my left hand sum, I'm going to do the object properties, and I'm going to use that I variable to determine what is displayed. So it says condition to show object. I'm going to let this be I equals 1. I'll let my midpoint be option 2. Let the right hand sum be option 4. I'll let the trapezoidal be option 3. and then I'll let the integral itself be the last option. Oh, that one didn't take. It's going to be I equals 4. Alright, let's see if that works. So now as I select option 1 is the left-hand sum, and I'll move these labels down below. Option number 2 is the midpoint sum, Riemann sum. Option number 3 is the trapezoidal sum. Option number 4, option number 5 is the actual area. And of course everything's dynamic. I can change the number of partitions. I can change the limits of integration, or where I'm going to actually calculate my sums. Go ahead and go back and okay, that's my angle. Here's my options. Let's put some labels underneath that option. So I'm going to add some text to my diagram here, and I'm just going to, hopefully I'll remember the order I did these in. I don't know why I put it way up there at the top. Right hand, trapezoidal, midpoints, left hand sums. And so I'll turn off the label. And there, that makes for a nice menu. So you can see the commands that I entered up here. I'll go ahead and change this to command, and now you can see the different parameters and commands that I use to enter those Riemann sums. So now we can look at the different values for our different methods of calculating Riemann sums and see which ones are overestimates or underestimates. We could change the function to compare increasing and decreasing in different concavities. Let's go ahead and add in an estimate using Simpson's rule. And again, we type in the formula. And that, again, there's no shortcut for it. We just type in the formula, and then it gives us the value. And again, we can see how accurate it is for different functions and for different numbers of partitions. Okay, the last thing we're going to do is a volume of rotation. We're going to rotate a function about the x-axis. So up here in the menu items, we're going to select 3D graphics to open up a 3D graphics window. And right now, we can go ahead and rotate that a little bit. You can see the functions already displayed, and our A and B endpoints are displayed on the X and Y axis. When I rotate the function about the x-axis, I don't want to use the entire function, so I'm going to define a new function, P of X. I'm going to use the function command, and the parameters I'm going to use the function F. And just like we were doing for everything else, we're going to use the X and B endpoints. So now we've got a partial function, and then we're going to use the surface command. Surface requires a function, so we'll use P, and an angle. Earlier we defined a slider using the Greek letter alpha, and when we hit enter there, you'll notice in the 3D window we're now doing the partial function revolved around the x-axis. We can move these sliders back and forth to give us different limits of integration or different portions of the function to revolve. Over here in the 3D window, we can pan, rotate, look at everything. We can kind of look a straight on view from looking down the z-axis to see how it looks, and then rotate it to get a good feel for what the volume of revolution would look like. Hope you guys enjoyed it. I know it was quick and hope not too confusing. We'll try and answer more questions in the question and answer session if anybody has anything. Thanks a lot.